So yesterday, guys, we had a chance to introduce inequalities. We got to talk about how we have different signs. We've got greater than, less than, greater than or equal to, less than or equal to, and we saw the difference between those and an equation. With an equation, we know that x equals 6. That's the only value x could be, right? It just equals 6. But once you start saying x is greater than 6, what are some numbers that could be greater than 6 that could work for this? 7. Wait, really? Give me a bigger number than 7. What?
10.
How about what's your favorite number?
15.
Hey, 15 is bigger than 6. Why didn't you go with that? Yeah, so we had a lot of options here. We saw that how to graph these. So we saw that sometimes you're going to have the variable on the right side of the inequality. And is it okay to have the variable on the right side? Absolutely. The only problem with that is you can't really follow the arrow for shading if the variable's on the right side. If the variable's on the left side, the shading just follows the arrow. So for example, 7 is greater than or equal to x. That's also x is less than or equal to 7, isn't it? So we can flip this around, write it this way, and now we can just follow the arrow. We know we're shading to the left, and so we've got B, shading to the left. We also dealt with some word problems here, and I know this was kind of confusing for some people. You know, at most, no more than, no less than, at least. Some of those can be a little confusing. Just know that if you see the word no in front of more than, it's just the opposite of more. And what's the opposite of more? Less. Or at most. I think that one was on here. Or actually, I'm sorry, no less. Is at most, yeah. If you see that at most, if I told you, Shelby, to run at most 5 miles, number one, you'd punch me in the face. Number two, if I told you to run at most 5 miles, would that be 5 or more or 5 or less? Ooh, no.
Less.
At less, right? At most means like that's as high as you can go. So we said less than or equal to. Now today, this is where this gets a little bit more complicated because what are we looking at here, Shelby? We want to know how to work with, yeah, and I want you guys to think about that word compounds. When you think of the word compound, what maybe comes to your mind? Really? I think of chemistry. A compound is two things coming together to make something new. You probably haven't had chemistry yet, have you?
No.
So compound is two things put together. And so if you look, a compound inequality, that's just two inequalities put together. So two inequalities that have been put together. Like, check it out. Look at number 1 for me. How many variables do you see in the inequality of number 1? There's just one. But how many signs do you see in this? 2. What this is really saying, this is saying that E is greater than or equal to which one? -4 or 1? Which one is E greater than or equal to? Yep, -4. And what else is E? It could be 1 or it could be less than 1, right? You see that? E is bigger than -4, isn't it? And E is less than or equal to -1. Does that make sense? This is two inequalities put together. E could be both, couldn't it? What, is that kind of confusing you a little bit?
Yeah.
So guys, this is an example of an and problem. When we talk about compound inequalities, there are going to be and problems and there's going to be or problems, right? It could be both these things, or it could be one thing or another. So we have ands and or probs. This is an example of an and problem. And guess what? All and problems have similar graphs. Because let's put a dot down. Where will one dot go here? What number do you see in number 1 here? Do you see a number? How about 1? Will this be an open or closed dot? Yes, ma'am. It will be closed because E could be equal to 1. Where's our other dot going to go? -4. Will it be open or closed? Closed. because E could be equal to -4. And let's start with -4. If E could be bigger than -4, where are we shading? Left or right? Yep, to the right. We're going to the right, going to the right. Oh, shoot. What happens here? Once we get to 1, what does E have to be? Yeah. So we're kind of stuck in the middle here, aren't we? Check it out. E could be bigger than -4, but it's got to be less than 1. So like Shelby here, she gave me a number. She said, hey, -2. That's something E could be, right? -2, E could be that. It's bigger than that, but less than that. I'm going to let you guys try number 2. And sorry, there's a typo here. That R shouldn't be there. Normally, you will see it written like this. But I just wanted to show you guys that if you see this, this is really what's going on. So try number 2 for me. So guys, we've got a dot on 0 and a dot on 3. Now, Shelby, are these going to be open or closed? Open. Because there is no equal to sign here. These are both open. Now, if x is bigger than 0, which way are we shading from 0, left or right? Right? Ooh, what happens once we get to the 3? X has to be less than 3. So which way do we shade? Left. And so what's maybe a number that x could be? 2. Sure, x could be 2. How about another number? 1. The 2 you see there. Could it be 1.5? Sure. Yeah, x could be a bunch of numbers, guys. So what this is saying x could be any number between 0 and 3. So this is an and problem also. Both these were. Now, let's take a look at the ones that are a little bit more complicated for some people. Let's look at or problems. Let's look at number 3. Number 3, what do you think makes this an or problem? It has the word or in it. That's right. So with these problems, guys, these are going to be where we have variables that can't be both things. Check this out. G is less than -3. So we'd put a dot at -3, wouldn't we? And which way are the numbers smaller than -3? To the left. Yep. But, or G could be greater than or equal to 4. And would that be a filled-in dot or an open dot? Yep. And which way are the numbers bigger than 4? To the right. Ooh. Does the shading ever intersect here? No, it doesn't. Because there is no number in existence. G could be. That would be less than -3 and bigger than 4, right? No number exists that's smaller than -3 and bigger than 4. So this is an or problem. G could be one thing, or G could be the other thing. It couldn't be both. G could be one thing, or G could be the other. It could not be both. That's an or problem. There is no value that exists that G could be that be both of those. So what I'm going to let you guys do, I'm going to let you try number 4. Whenever I unfreeze the video, we'll have that answered for you. And then we're going to get into actually writing inequalities for these graphs. So number 4, we've got a point at -4 and a point at 4. Are they filled in or open?
Filled in.
Yep. Filled in because P could be equal to both of those. And if P is bigger than or equal to -4, shading to the right. If P is less than or equal to 4, shading to the left. And what kind of problem do we have here?
And.
We got an and problem, shading in the middle. If I could show you guys the ends of my fingers are the points, and that shading is going together. I like to use my elbows, but you guys can't see it right now. And honestly, guys, if you can do the graphs, you can reverse this very easily. It's not hard at all to say, okay, if I'm given the inequality, I can do the graph. Now, what happens if I'm given the graph? Oh, I can do the inequality. And in fact, just by looking at the graph, you know if you have an and or an or problem. Let's check out number 1. Is that going to be an and or an or problem? Or shading is going away from each other. I immediately know that. And Shelby, what variable would you like to use for this one? Are you kidding me? My live audience has chosen to go with the most boring variable imaginable. We got x, and we know we're going to have x over here. Now, how does x compare to 2? Is it bigger or smaller than 2? Smaller than 2. So x is less than 2. Or how does x compare to 3? Bigger, and could it be equal to 3? Yes, it could. So x is less than 2, or x is greater than or equal to 3. How about let's hop down and do number 3 together, and then I'll turn you guys loose on 2 and 4. So look at number 3. We're dealing with an and or an or problem. And. Now these are a little bit tougher to write for some people. What are going to be our 2 endpoints here?
0,
Okay, -5 and 0. Now what variable? Remember, our shading, don't forget guys, the shading represents the variable. It represents all the numbers that the variable could be, right? So what variable would you like to use here?
S.
I thought you were going to say x again. S. Now, how does S, let's start on the right side. It's always easier if you start on the right side. How does S compare to 0? Is it less than or greater than? Less than. S is less than 0. And here's a pro tip. The arrows always have to go the same direction in an AND problem. In an AND problem, arrows go the same way. That's a good way to help you from not making that mistake. And you just kind of know anyway, because how does S compare to -5? Is S bigger than or smaller than -5? Bigger. So the arrows go the same way because S is greater than -5. Great job so far, guys. I'm going to let you try number 2 and number 4, and then I'm going to go ahead and let you guys see if you can combine our first page knowledge with the back page knowledge, and we're going to see if we can solve some of these. Let's see if we can solve 1 and 2 along with 2 and 4 up here, and then graph our solutions. And then I'll bring it back and I'll do number 3 with you, because I'd say most of you guys are not ready yet to handle number 3. So we got these 4 problems I want you to try here. And on these bottom 2, we're going to solve and graph. So let's see how you guys did. We got number 2, a classic OR problem. We've got B being less than or equal to and greater than or equal to those 2 numbers. Number 4 is an AND problem. Our variable is stuck between these 2 points. It's bigger than or equal to 0, but it is smaller than 5. And then down here, we solve these just like an equation. You add 3 over. K is less than -4. And if it's less than -4, we shape to the left. Now, major key alert. Shout out to that guy who's got no talent, DJ Khaled. If we're going to solve these, there is one major difference between solving an inequality and solving an equation. If you divide or multiply by a, here it comes, negative number. If you divide or multiply by a negative number, you have to flip the sign. And guys, that's going to be a mistake I already know we're going to make. So don't panic. I just know we're going to make it. It happens every year. If you divide or multiply by a negative number, you have to flip the inequality sign. So look at number 2. We've got -1 being multiplied to n, don't we? How could you solve for n if there's a -1 being multiplied to it? Well, you can't add it because it's being multiplied. You would do the opposite of multiplication. You would divide it. So if there's a -1 being multiplied to n, we have to divide by -1. And if you divide by a negative, not only is it going to turn that 2 into a -2, you have to flip that greater than sign. So that greater than sign now becomes a less than sign. I know that's going to get some people. So just please take your time on that one. The other part's a little bit easier over here. We can add 3. That gives us 2n is greater than 8. And then if you divide by 2, n is going to be greater than 4. And so I know this is an OR problem. They told us that at the beginning. So we put down our point at -2. We put down our point at 4. And since it's an OR problem, that means we're shading to the left and we're shading to the right. So what I like here, guys, I like that we've done an example of a regular inequality. We've done an example of an OR problem. Well, guess what that leaves us with? Let's look at number 3. What kind of problem are we dealing with, Shelby? Is this normal or and? Now, wait a minute.
It's starting out and.
It is, because do you actually see the word or in here? No, OR problems will always have that word there. You'll always be able to tell it's an OR problem. Yep. Now here's the tricky part. Where's our variable at? Is it on the left, middle, or right side?
Middle.
It's in the middle. So to solve it, we need to move everything out of the middle to get h by itself in there. So what would you like to move first that's in the middle? Yeah, don't forget our steps, guys. Here's the tricky part. When we subtract 2, which side do we subtract it to? Fun fact, we have to keep things balanced, don't we? So to keep things balanced, not only do you subtract it from the left side, you subtract it from the right side too. That's right, we got to keep balance. So let me bring this up here. That leaves us with 3 is less than 3h, which is less than or equal to 9. So we had to subtract 2 from every side to keep this balanced. Well, guess what that means we're going to have to do if we have 3 times h? Divide it, and we're going to divide it to every side. And so, again, we divided by a positive 3. So, guys, these signs will not flip. These signs stay the exact same. So 3 divided by 3 gives you 1. 9 divided by 3 gives you 3. And there's our solution. So let's put down our number line. I'll put 1 here, 2 here, 3, 4, 5, 6, 0, -1. Now we know we're going to have a point at 1 and a point at 3. And which one of these points, Shelby, will be filled in? Will it be 1 or 3? 3, yes, ma'am. And because this is an and problem, will our shading go out or in? In. Yep. H could be between 1 and 3. In fact, what's a number that H could be that's between 1 and 3? H could be 2. That's right. So, that was a little bit tougher, guys. So don't feel bad at all if that one tripped you up a little bit. Don't feel bad at all. So last section. Now, some of these absolutely destroy us. They throw us out a window. We want to be able to write this statement. So they're going to give us the statement in words, and we actually have to write the inequality. We did these for our equations, and I know this really gave some of you guys some problems. But again, the secret to these is look for where the word is. That's really confusing. Is greater than. Check it out down here. Is at most. Or 2 times the number is at least. Number 3, the sum of 5 times the number and 7 is, there's that word is, between. The product of -7 and a number is greater than or less than. And I'll go ahead and give you a hint. Some of these are going to be compound inequalities. But let's just take them one step at a time here. Shelby, 2 times a number. What do you want to call that number we don't know? Z. I like it. 2 times Z. And then what do we have next here? Plus 1. Hey, and here's our inequality sign. Is greater than. So what sign are we going to use? Greater than sign. Yep. And what's it greater than? Well, we've got 5. So it's greater than 5, right? So greater than 5. Ooh, wait. And less than 7. Uh-oh. So we have is greater than, and then we also have less than. So what's the word you see between these? And. Ooh, so it's greater than 5. What are we going to have to put over here? Less than 7. This is an and problem, guys. Sometimes you have to be on the lookout for that word right there. You got to be on the lookout for if we see an and or an or. They may show up and surprise us. How about number 2? A number, I'll call this C, minus 1. Is at most 9. Now, at most, does that mean less than or greater than? Less than or equal to 9. And then, oh shoot, what do you guys see immediately after? Or 2 times the number. What do we call that number? It is C. So or 2 times C is at least. What would that be? Greater than or equal to 24. So guys, it's kind of tricky. We got to just watch out for the words or and the words is. So kind of see you had 2 there. I'm going to let you guys try 3 and 4, and then we're going to wrap up for the day. Last 2, guys. I know these last 2 were a little tricky because you're thinking, wait a minute, on these previous ones, we've always had the 2 things split up here, whether it was and or. Here it says between. Well, guys, look back at our graphs. Which one of these do we use between for our variable? Oh, like number 4, C is between 0 and 5. That's when we have an and problem. So if the sum of 5 times a number and 7, the sum of 5 times a number and 7, that means 5z plus 7 is going to be between negative 9 and 11. If it's between them, that means it's going to be bigger than negative 9 and smaller than 11, right? It's going to fall somewhere in the middle. So we say this is smaller than 11, but it's bigger than negative 9. So that puts it in the middle. So that is an and problem. And speaking of something that's not an and problem, check out this next one. The product of negative 7 and a number. Shelby, what do you want to call that number? H. That's my second favorite letter. Is greater than 30. Okay, well that's simple. Ooh, what's that word right there? Or. Or is less than 15, so we still use negative 7h. That part doesn't change. But negative 7h is either greater than 30 or it is less than 15. And that is an or problem. Now, ladies and gentlemen, if you have any questions, you know how to get in contact with me. If you want to reach me over the weekend, your best chance is to use Remind, but you can always email me as well. And I'll be talking to you guys soon.